Hello and welcome back to Pie for Dinner. In today's video, we're going to be reviewing how to evaluate if a function is continuous at a point. In calculus, a function is considered continuous if it is unbroken and has no abrupt changes or holes within its domain. This means that the graph of the function can be drawn without lifting your pencil from the paper. To determine if a function is continuous at a specific point, we need to check three conditions. Condition 1. The function must be defined at the point. In other words, there should be no holes or missing values in the function's domain. If there is any point where the function is undefined, such as dividing by 0 or taking the square root of a negative number, then the function is not continuous at that point. Condition 2. The limit of the function as x approaches the point must exist. This condition ensures that as x gets close to the given point, the function's values approach a finite number. In simpler terms, the function should not have wild or erratic behavior as x approaches the point. If the limit of the function exists and is a finite value, it satisfies this condition. Condition 3. The limit of the function as x approaches the point must be equal to the value of the function at that point. This condition ensures that there is a smooth and seamless connection between the function's values approaching the point and the actual value of the function at that point. If the limit of the function as x approaches the point is equal to the function's value at that point, it indicates a continuous transition without any abrupt jumps or discontinuities. And now we will do a few example problems showing how to apply these conditions. In this problem, we will start by evaluating the limit of the function as it approaches -3. We see that the numerator is a polynomial, meaning we can factor it out. By doing so, we see that we can cancel a term in the numerator with the denominator. Now we can evaluate the limit as it approaches from the positive side giving us a value of -6, and as it approaches from the negative side, giving us a value again of -6. Now we will evaluate the function at the point. Which leaves us with 0 over 0, and we know that if the value of the function is divided by 0, it is not defined, meaning that this function is not continuous. We also know that if the value of the function at that point is not equal to the value that it approaches at that point, it is not continuous. For our next function, we will evaluate the limit as it approaches 3 from the negative side. We will use the portion of the function when the x is less than 3. Giving us a value of -2. And as we approach from the positive side, we'll use the part of the function for when x is greater than 3. giving us a value of 2. And because a negative 2 and 2 are not equal, the function does not approach the same value on both sides, meaning that this function is not continuous. We know a function is continuous if it is continuous over its entire domain. And so for this problem, we will separate the numerator and denominator into 2 different functions, g of x and h of x. And we will establish that the domain of our function f of x is x greater than negative 5. And so by using the 2 parts of our function, we know that one is continuous along our domain. And we know that the square root of x plus 5 when x is greater than negative 5 is also continuous along our domain. Therefore, we can establish that our function is a composition of continuous functions, and which makes our function f of x continuous. Which makes our function f of x continuous. In our next problem, we will evaluate the limit of the function as it approaches 2 from the negative side. And so we'll use the function when x is less than 2. Leaving us with a value of 1. Now we will evaluate as x approaches 2 from the positive side. And so we'll use the function when x is greater than 2. Which will give us a value of 2. And because these limits are not equal, meaning that the function is not approaching the same number on both sides, the function is not continuous. Okay, thank you for watching and have a nice day. Thank you for watching and have a nice day. Make sure you like, comment, and subscribe. And if you have any questions, make sure to leave them in the comments.